Alright, we've got a situation where Hugh's trying to get across a perfectly circular pond. And he doesn't want to walk around the edge because that would take too long, so instead he's going to row across part of the pond and walk the rest. And for some strange reason, we're looking at the maximum time it should take you to do this trip. Maybe it's a beautiful circular pond, and he's trying to spend as much time traversing it as possible. Let's unpack the mathematics a little bit here. We have to figure out the distance, rate, time. We're looking at time as the thing that we're trying to optimize, and we know the rates of canoeing and walking, so what we really need to find here are some distances. The first distance we need to find is the distance PQ, PQ being the distance that he rows. And so when I unpack this a little bit in terms of the geometry, I can see here that the radii form an isosceles triangle, and I can find half of the base of the isosceles triangle by using right triangle trig. So I see the relationship between 2a and theta as a cosine ratio, so I establish the cosine of theta is a over 2, or the length a is 2 cosine of theta. Now here we establish, I jumped ahead a little bit here, that PQ is 2 of those A lengths, therefore 2 times 2 cosine theta, or 4 cosine theta. So that is the length of PQ. Now I need to find a little bit more. First of all, I reminded that distance equals rate times time over in the upper right hand corner over here, and so I utilized that to find T1, and I define T1 as the time it takes to row. Therefore T1 is actually going to equal PQ over 3, because 3 represents the rowing speed, so this distance over this time. Keeps writing on here. Anyway, so we take this distance across the pond divided by this rate will give me the amount of time it takes to row, and that should be equal to the PQ length divided by 3, or 4/3 cosine theta. The other thing that we need to find is the length of the arc QR, and so here's what I learned in geometry, that the arc length is going to be the radius times the angle. In this case we're going to call it phi. And so there's 2 of those because the radius is 2. Then we're going to have r theta representing the arc length. Then I learned that this inscribed angle will always be half of the central angle, and therefore we can establish that QR is 4 theta. So remember, theta is actually describing arc lengths, so theta, in spite of being an angle, is actually describing the length of this arc right here, and if I take 4 times the angle theta, that will be how long this thing is. Then, using the same distance rate time relationship, I can establish that the time it takes to walk along the shore is the arc QR length divided by 5 kilometers per hour, giving us the total hours of 4/5 theta. And then the total time it takes to walk and row is described here. Now comes the calculus. Once again, the time it takes to row entirely is determined by this function, and we should note this depends on theta. So the rate that the dude walks and rows, none of that's going to change. What's going to change is the angle that he chooses to point to Q. So if I make it a smaller angle, I'm going to land closer to R. The larger angle, I'm going to land further to R, and it's going to affect the amount of time it takes to make this trip. So my job is to find the rate of change so I can optimize here, maximize or minimize. So I take the derivative, I set the derivative equal to 0, and I find out that in order to make this work, the sine of theta has to be equal to 3/5. Looks like a 3, 4, 5 triangle. Find the inverse sine, and I mentioned in degrees or radians. Inverse sine of 3/5 gives me a 36 or almost 37 degree angle to row, and that's about 0.643 radians. This can actually be verified using our technology, and here we see that indeed the maximum occurs at the right place. Now, I was thinking about what the max domain is, and originally I thought it was going to be pi, but because we're inscribed there, I think pi over 2 is going to be the largest angle that the dude can choose to row, which would make it so he doesn't really go across the pond at all. He just walks the whole arc. Anyway, I also know that it's going to take him 1.581 hours to complete the journey if he rows at about a 40-degree angle to get to point Q. So that's the math, yo. Have a great day.